Hello and welcome to this lesson on obtaining metals from their compounds. In today's lesson, we will explore the method of displacement used to extract metals from their compounds. Then, we will understand the use of electrolysis in obtaining metals from their compounds. So far in this unit, we've outlined our dependence on the Earth's resources and ways in which we can ensure sustainable development. This module on naturally builds on these ideas, focusing on how we obtain the metals which modern life depends on. Let's get started! Displacement reactions involve using a more reactive metal to displace a less reactive metal from a solution of its compound. One common example is using iron to extract copper from copper sulfate solution. Here's the reaction formula for clarity. CuSO4 plus Fe becomes Cu plus FeSO4. In this reaction, copper sulfate is in a solution form and iron is in its solid state. When scrap iron is added to the copper sulfate solution, a chemical reaction occurs. The more reactive iron displaces the copper, forming iron sulfate, or FeSO4, and pure copper metal, Cu, which is deposited as a solid. Electrolysis is a process that uses electric current to reduce metal ions to pure metal. This method is often used when the metal is too reactive to be extracted by displacement. Let's consider purifying copper using electrolysis. An electrolysis cell is set up with two electrodes immersed in a copper sulfate solution. The setup involves a positive electrode, called an anode, made of impure copper, and a negative electrode, a cathode, where pure copper will be deposited. When an electric current is passed through the solution, copper ions from the copper sulfate solution move to the cathode, gain electrons, and get reduced to form pure copper metal. At the same time, copper atoms from the impure anode lose electrons to become copper ions and dissolve into the solution, maintaining the concentration of copper ions in the solution. The reactions at the electrodes can be described as at the cathode, Cu2 plus 2E minus becomes Cu, and at the anode, Cu becomes Cu2 plus 2E minus. In this way, the copper metal is purified, leaving impurities from the anode behind. In these reactions, displacement and electrolysis both play vital roles in efficiently extracting and purifying metals, making these techniques essential in the field of metal extraction and resource utilization. In today's lesson, we explored two primary methods of obtaining metals from their compounds: displacement and electrolysis. We began by discussing the displacement method, where a more reactive metal, such as iron, is used to displace a less reactive metal, like copper, from a solution of its compound. Next, we delved into the electrolysis method, which uses electric current to reduce metal ions to pure metal. We also highlighted how displacement and electrolysis can be combined to enhance metal extraction and purification, emphasizing their importance in the efficient utilization of metal resources. This lesson has provided a comprehensive understanding of these crucial extraction techniques. Watch the rest of the GCSE chemistry course at Sophos Education.